Hello everybody, welcome to another stream. Right, that should be fixed there, then I'll fix the desktop audio. Hasn't happened in a while. Welcome back everyone. Right, it's posted live. Right, we're completely unprepared. Let's get my laptop on. Ding! Welcome chat, how you doing? So today we're doing entities. Whoa. We're going to be starting from scratch, but going through and designing a whole entity thing. So last stream we covered this game tech plan, which is for the next probably 8 months at most. I'll post it on the Discord now. Game tech plan. We went over all this. So the idea is to build an editor, right, for the game. But obviously we need to do other things before we get there. So the first thing is an entity system. So that's what we're starting on today, and we're going to start with a plan. So let me just copy and paste this into the Discord. Plan for the next about 8 months. Drop that in there. Sorry, I just got to sign in on my laptop into Twitch for some reason. Hang on a minute. What's going on? Ah, there we go, I'm signed in. Wrong browser. Cool. Right. Oh yeah, you can't post big messages in. Alright, just drag the file in. Because I don't have Nitro, I think they call it. Done. So you upload a file instead. Right, so let's talk about entities and go through the different. Just go through the thought pattern of how are we going to tackle the entity problem and plan the whole thing out. I've already gone over it in my head, but I'm sort of taking it from the beginning for you guys. And if you have any questions along the way, feel free to ask. Let me figure this one out. So we want to just get rid of. Right, and then maybe another one might be like a tree or something, I imagine. Right, these are the quickest examples I could come up with, but it gets the idea across. Okay. Hello everyone, welcome to another devlog. So today we're going to go over the entity system that we're going to be designing for the game that we're going to be working on. Do want to say it that way. Hello everyone, welcome to another devlog. So today we're going to be going over the entity system and we're going to design it all from the beginning and just take you through the thought process that we're approaching for this game. Okay, that's good. So on the screen here, what you see is that there's really two different ways that you can approach entities in a way. You can kind of just group every single field that you possibly need into one entity structure and just have like an entity just has everything in there. So no matter what entity type it is, it can just do anything you want. Another kind of approach is this sort of archetype approach, where you sort of like break your entities down into distinct types. They're hard-coded into different types. And you simply take the fields, you only put the fields in there that you need for that type. So the knight has basically all of them, right? And the chest is missing the weapon and armor slot, and the tree is missing the inventory as well. Hey Lich, how's it going? Welcome, sir. How are you? How are you? But obviously, in a real game, you can have tons more properties or whatever you want to call them, fields. And these things... But in a real game, you're going to have tons more fields and properties. And so really, the mega entity structure can actually get quite big. And also you end up with tons of different types. And it could get maybe quite crazy trying to deal with all the different types as a hard-coded type in the type system, right, at compile time. Are we trying to make an ECS, or is this supposed to be just a simple, straightforward implementation where each entity is just all the data and logic in one? Bum bum bum. We got tune in to find out. So I don't want to call it an ECS, but it could it's probably like, but it will definitely borrow things from it, because one thing is I don't want to do the S part of ECS. I think it's a very bad idea to make systems part of the entity system, because yeah, there's more to games than just entities. But if you say like ordering stuff in SOA is ECS, then maybe we're doing an ECS thing by that logic. But yeah, we'll probably be doing more of a data-oriented version of entities. Let's leave it at that. And the reason is because we have tons and tons of entities. Like I've only had a few, maybe not, but I think it will probably be beneficial if it was at least thought out a little bit, so we can optimize it a bit more later. Rather than just doing a big old fat entity thing. But we'll see how it goes. I don't think I'm going to have massive amount of archetypes, I don't think. But it'd be good if they all split up. So a nice thing about the approach with the sort of mega entity is you have one type and everything is that type. All functions that you make work with that type. You don't have to make different functions for every different type. And if you want to iterate over every entity with a particular field, say you want to look, say if you're saying, hey, all of the entities that are around me right now, can I look at all of the health of those entities? And I want to obviously attack the one with the least health. If you do that with the archetype approach, you might have to make a function which iterates over all the different entity types, and then does specific logic there, so it can get quite fiddly there too. What else would I like to describe with the archetype verse? Yeah, I guess I could quickly mention that there is the OOP extension of archetype, but we're not going to bother with that, right? If you have the archetype approach, how can you try to store a list of different entities? Yeah, you just do different. Yeah, we'll get into it. We'll be getting into that. But basically, we're going to be having we'll have handles for entities, and we'll have pools of different entity types, archetypes. Archetypes solve a very specific problem, which we can't really get into right now at this level of the explanation. So archetypes. What else do I want to mention about them? Anything? But obviously the thing that is improved over the archetype approach is you will use less memory, especially when this entity type this mega entity type just gets bigger and bigger and bigger because it's got to fit more fields. There'll be less wasted memory. And also with the archetype approach, you might also get better access patterns if you read every single field in your strut. They're more tightly packed together, so you might get better performance, but I don't think you typically get that when it comes to reading properties of an entity. Wait, let's say the one again. Another thing you get with the archetype approach is that the fields are more tightly packed together versus the entity one, because entity one could just have every single field in. So you'll just have a bunch of like padding basically between the fields that are actually used and not used for this entity type. Whereas like for an archetype one, they're all tightly packed together. But I think it's kind of rare where you want to pick up an entity and see and read every single field from that entity for a particular task that's processing that entity right now. Typically, you just want to say check the health, right? You don't want to check everything else about it, usually. Right. Okay. So do you just store an enemy type enum field on every entity and dynamically allocate the required space and cast a void pointer? No? That's like a union. No. Because yeah, that's one way of doing it. Yeah, that's definitely one way of doing it. You could do like a union. But there's other approaches which we're going to get into one. The problem with the union is you waste space. Right, so how do I move into the next section? Oh yeah, I want to describe the type of game, the game they're making, and why we need to. Right. Okay, so if the game was just going to have 1,000 or so entities, I wouldn't necessarily bother trying to worry about this code so much. But the game that we're going to be making, I've estimated around 73,000 entities to be simulated, probably all within the same frame, maybe over a few frames. So I would like to just at least pay a little bit of attention to designing this thing more properly. And hey Clarissa, how's it going? How are you, my friend? How's your day going? So if my game had under 1,000 entities, or maybe a few thousand, whatever, I maybe wouldn't worry so much about the structure of my entities. I'll probably just go with the easy approach, which is this first one here, where we have all the fields in a single entity, because it's the most flexible. But I've estimated that my game is probably going to have around 73,000 entities being simulated. So I'd like to just pay a little bit of attention to this now, such that later on it won't be so much of a pain to refactor. Yeah. Okay. Doing fine, excited about the DoD, but a bit sleepy. Oh no. Yeah. I managed to convince myself to go DoD because, I was like, if I'm going to have to multi-thread these entities to get them to run within a frame on lower hardware or whatever, I've got to leave the door open for SIMD in the future. So doing it this way leaves the door open for SIMD at least. And also should be, hopefully be better. I've been doing a lot of thinking it should be alright, but we'll see how it comes when I think when we have a system in place, we should be able to change it and tweak it as but keep the public interface relatively the same, I think. Just change how the storage works, if need be. Nice. Yeah, Silver Core. We're in game technology. I don't know if you're on the Discord or if you watched the previous stream. I'm trying to get the previous stream condensed down into a devlog, but it was so damn warm yesterday. I pried myself away from the computer. But we spent time, made this and refined this. Well, I made it actually over Friday and Saturday, then we refined it more. It's the next 8 months worth of work. So we're doing the game technology, like entities, multi-threading, encoding and decoding assets, very basic asset system, just loading from a folder. A way to make levels, because we have instances now. So, I've decided rendering is going on a pause, and just get the rest of the game technology into a good place. This is just a 5x5 grid of instances, which are an 8x8 grid of ellipsoids rotating, and the performance isn't the best, but it will do for now. We can make the performance better soon. I cannot fathom an engine that's just built with that isn't built with the most optimized ECS framework plus asset streaming text system. Oh. Yeah, I'm only doing it. Yeah, see, the name ECS is. I'm not doing an ECS, but it's probably quite similar to what people think ECS is. Because the problem is with ECS is such a butchered thing right now. You know what I mean? We have to have is entities and components and operate on them, and then like you're an ECS. So, hey Jack, how's it going? But yeah, most optimized. Yeah, maybe it'll be optimized. This is the hope. Hopefully optimizing prematurely, which is the way. Well, it's not prematurely. This is just-in-time optimization, when I'm writing the code in the first place. How you doing, Jack? Welcome. So imagine, again, we have that scenario. We're trying to find all the knights in the area which have a certain health. That we can, pick the one with the least health to attack that one first. So what we're going to be doing is iterating over all of these knights. We'll read the health field, and then we'll also read the coordinate field and get like a distance from our character, and also get the health and work out basically like the one that's kind of closest but also with the least health. We'll go and attack that one first. So we're just using a couple of fields here. We're not bothering looking at their weapon or armor. For some reason, the algorithm doesn't do that, but imagine it's just these two fields. So when you're going over this array of knights, you're only looking at these two fields, and the rest of them you are not looking at. So let's add this all up for a sec. Yeah, the problem is this is not. I need to maybe make better examples. So that would be 4, 8. What's that? Half a. Yeah, that's 32 bytes, isn't it? So it's half a cache line. Easy. What keep me busy? Yeah, I know, man. I was so tired today at work. Just so busy. You got any performance numbers to start with? Know if you're going to be in the right direction. So, good question. I'm going to be writing a way so I'll be able to test both systems quite easily. So yeah, we're probably going to be doing a code generator. So I should be able to code gen it to be SOA and then AOS, such that we should be able to see at least what the performance is, how much gains we're getting by doing it that way, before we do any SSE or AVX intrinsics, which I won't be doing for a long time, but it leaves the door open for that. In a way, people who build a generic ECS frameworks are working against data-oriented programming. The whole point of data programming is to specialize code for specific game hardware run on, but I digress. Yeah, exactly. Yes. That's what I'm calling like DoD entities. Because it's also without the S. The S is a separate thing. It's a job system, right? It's outside of entities. It's not part of the entity system. Yeah. Yes, this is 32 bytes. Right, there we go. So if you know anything about CPUs and CPU caches and the way they work, you'll be looking at this and you realize, hang on a minute, this is half a cache line. So it's 32 bytes. So you'll be able to, whenever you go over this array of knights and you start looking at this character here, you'll probably load this knight and the next one if this is aligned to a cache line, and then you would look at the next knight and you'll be able to read that one from cache super quick. So you pick up those fields in the next knight. But when you go to the knight afterwards, you'd have to pull in another cache line from main memory, and then also just pick up those two fields, coordinate and health, and then operate on that data there. So essentially the rest of the fields are kind of wasted in this operation. We are scanning over these nights and polluting our cache on our CPU with a bunch of data that we don't actually need. So this is going to have an impact on performance when it comes to reading over a bunch of entities just to check if the health is low enough for us to attack. Not gonna lie, my first thought was those IDs, do they need to be U32s? Yeah, of course they do. All IDs are Yeah. Yeah, some of them probably wouldn't. SOA, structure of arrays and array of structures. We'll be getting more into that in a bit. Or you have one big structure of array fixed max count all entities. Yeah, that's something we're going to get into as well. Kumar. That's something we are going to touch on and talk about different things. That is probably next. Yeah, so I guess if someone wants to learn about CPU caches, they can bother learning that themselves. Should I do a quick diagram? Maybe at least get some numbers. No, right. So the CPU isn't just as like... So there's also something to take note with the CPU. When it reads over the first 2 nights, it's probably going to predict that it's going to read the 3rd night and the 4th night. So what it will probably do is already start fetching that cache line, those 64 bytes of memory from main memory, and load them into the cache, ready for when the CPU gets to those next instructions. But the problem is that it's still reading in more memory than it needs to, and also that that prediction saves you a bit of time, but you're still going to end up having to wait probably because the prediction is probably not going to. See, that's where my knowledge kind of fades a bit. So maybe just mention the prediction. Roll optimization, get numbers first. Yes, very much so. Numbers are hard. I've got one number and it's just tons of entities. So that's what we're going to roll with. Right, so one thing to take note about the CPU is when it reads the night 0 and 1 in the array, and it's already pulled in that cache line, it's probably going to predict that you're going to go and read the 3rd and 4th night. So it could preemptively go out and prefetch that cache line from main memory and pull that into the cache. But you're relying on that system to do it in time, because you might quickly operate on that night data and you still have to wait for that memory to come back. And also, again, you're still wasting the cache with extra memory that you're simply not going to look at. Right. So maybe I can get some brief numbers. There's just some quick numbers that are not necessarily true, but at least within the ballpark of being correct. I wonder how much they change anyway. I forget the numbers exactly. Um, see, this one's a bit too much. Here we go. Here's some numbers. It's tricky for planning for SIMD because for coordinates, best case, because you store n times n. Oh, ny. Oh yeah, nx's, ny's, and nz's. Yes. Yes. See, that's what I was thinking about that. Like storing all the x's next to each other, all the y's next to each other. But I think it might just be best just to store x, y, z, and just have a wasted fourth component, or reading a float 3, like just process them in the standard XYZ order, and it should yeah, it should be able to be okay. Might have to put a bit of padding in there, but at least be better than nothing. But yeah, maybe we can change maybe swizzle it later on. As long as your access pattern is predictable, X%, right, etc. The prefetch is what's pretty nice. As far as I know, it doesn't really have to be contiguous memory. Small strides also be predicted, although that obviously helps by maximizing cache. Yep. They said if your game needs to be 100 entities or max. Yeah, exactly. Yeah, we're not doing I think we're going to be planning to have 73,000 entities. So this is why I'm thinking about it now and doing a little bit of you're making a more complicated system basically. But I don't want to go too complicated and make a 15,000 line thing, right? And maintain that. So we're doing a different approach. L1 is about 5 cycles or less than 5. Right, memory 200. Wow. Ugh. Yeah, this thing's saying something here as well. Okay. Let's just point to this one. Right, so if you're... yeah, let's just do a quick... you know what? Let's not dive into the tech details about it. Someone else, they can figure out that. If they don't know what caches are, they can look into that themselves. I'm just assuming they know that. It's too much to go into, I think. No, we will mention it. It's going to be quite simple, I think. Right, so I've just words. So I've just done some quick googling into like how long. Yeah, it is bloody warm today. So I've just done some quick googling into how long do you have to wait if there is a cache miss. So if we try and read from a location of memory and it's not in cache, what is the penalty for that? So if it is in the L1 cache, which is the smallest cache but the fastest cache and it's closer to the CPU, typically it says here it's about 1 to 2 clock cycles. So that's just basically like the same as like an add operation. It's very, very quick if it's just there in cache. The L2 cache is much bigger, but also a bit further away. So this one takes a little bit longer as well. So this one will take 5 to 20 clock cycles roughly. Somewhere somewhere around these numbers are. They probably vary on from hardware to hardware. And then if you miss, there's also an L3 cache, which is probably somewhere around the ballpark of 50 clock cycles or maybe a little bit more. And then if you miss all of those caches, you go to main memory, and these ones will end up probably being around like 200 clock cycles. And just so that time can just be used for other things, like actually performing operations on the data you've already read in, right? So ideally, you want to try and keep stuff in the L1 and L2 caches. You can store X, Y, Z, X, Y, Z, and operate on multiples of SIMD with entities at once, but that will cause some unnecessary shuffles at the end. Right. Okay. Yeah, storing them in Swiss orders XXX is very inconvenient. Maybe with this system we can handle that, because we'll probably generate it. But yeah, we can handle that in the future as well. The system needs that open for. Wow. I did not know that. That's interesting. Yeah, apparently it also used to be quicker to read from main memory in on older hardware. So the CPUs were so much slower that it was quicker to read pre-calculated data by fetching it in arrays. I remember seeing that. I'll set XYZ separately in my survey for particle effects. It works well and haven't run into any issues. Right. Well, if you store it in XXX, YYY, ZZZ, you've got to worry. You got to make your libraries around that, your maths libraries around that. It's not as easy as writing like shader code is. And shader code automatically does that stuff for you. You can only store registers that handle, for example. Oh, amazing. That's pretty sweet. I didn't know that. Right. So how could we tackle solving that problem when we lay out our data? So now we're going to copy paste it, go full ham. How could we possibly solve that? Mega entity array. So I'll rename it to like pool or something, right? Entity pool. And you probably want to have like, a bit set of like what fields exist or property. All right, something like that. So this type of layout is known as a structure of arrays. Wait, is that right? It's array of structures. Damn it. Right, so this structure and this type of data layout is known as an array of structures. So when you put your knights in an array, you have an array of struts, right? That's the way you think about it. So this one is typically quite poor when you want to operate on loads of data of the same field, because you've got to stride over all of the other fields to get to the same field in the other knight, for instance. But only for AVX 512. No. See, have they backported some of that into 256 and the 128 one? Because they do that sometimes. They add more instructions or more capabilities and then backport them. Have they done that? Chorus, that would be cool. Whereas this approach here is known as structure of arrays. So instead you have a single structure where each field is an array of all of the properties. So say if you have a knight at index 2, you would index into each of these arrays at slot 2. And that would be all the data for knight 2. So I've kept this whole mega entity concept and archetype concept, but now instead you have one single structure. We have arrays of properties, and this is every single property that could ever be in any entity. And you have so any entity can get any property just as simply as turning the bits on in the properties bit set. So if you have entity, say in slot 3, and you can read its bit set and know which slot 3 coordinates, health, mesh ID are going to be enabled for this type of entity. Yep. Whereas for the archetype approach, we just have arrays of all the fields that are possibly going to be used. Yeah. Whereas for the archetype approach, we just have arrays for all the properties that we're definitely going to be using for that archetype. And you could still add optional fields or optional properties for the knight and the chest and the tree, for instance. But that also comes with some downsides, which you'll see in a moment. There's one gather instruction in AVX 2, but that's about it, I think. Oh, okay. So should we make a nice... Should we make a nice table? We'll like a nice table here. Where we say like... So we'll say like coord, health. You know, I should have just done this, isn't it? Yeah. So... Right. So we could say entity at entity 0 is going to have a coordinate, right? This is going to really illustrate my point well, I think. We'll do a dash. Doesn't have health. Doesn't have a mesh. You know what, just won't do dashes. Yeah, let's just do this basically. So we do like an entity 1, 2, 3, 4, 5, 6, 7, 8. Let's say they all have coordinates. Why not? Alright. So do they all have health? Actually, just one of them has health. Let's see. Yeah, we're not focusing on that. Let's just do these ones for instance, right? And let's say yeah. Right, so with this approach, you might be thinking, great, everything's next to each other in memory, so now we should just be able to iterate over the fields that we only want to use, and we'll only be pulling in the data that we want to use, right? Well, not necessarily. So with this mega entity type, there's a problem where, say if not all entities have a health field, right? Because their properties bit set says you don't have a health component, if you will. So entities 0, 1, 3, 4, 5, 6, 7, 8 do not have health. So when you go and scan over and iterate these entities, you're looking for ones that have a health component, and you're only going to go and pick up one health component out of these 8 entities. So this has 2 problems. One, you'll be loading up a cache line and only maybe getting 1 health in there, but maybe you'll get more, because this is actually a U8 and it's actually quite small, so it's all nicely tightly packed together. So you can fit 64 of those in a single cache line, so maybe there is some more. But the other problem is that my mind completely lost it. No. I had the other problem, it just went out the window. And I forgot to put Paul in here. Let's correct that quick. So we mentioned that you're going over, you might only you got the same problem where the caches are not filled with healths that you were expecting there to be, right? You got the same problem still as you had before, but instead it's padding. It's like, or it's just empty. So, what was the other one? Yeah, that is true. It is definitely simpler and also flexible. It's got a benefit. You can just put anything you want on and not do archetypes and not be restricted to archetypes as well. But yeah. Yeah, I don't think it's going to suit this project. Man, I forgot what I was going to say now about that cache thing. So you're going to be going over those healths and, yeah, scanning over empty slots. You're not going to be fully utilizing your cache. Yeah, okay, there we go. Maybe that was it. I'll record it, and then if I find out something again, I'll come back. Right, so the first problem you have is that obviously you're going over these you're looping over these entity components. I wonder what's there before now. Well. Yep. Okay. Right, so there's a couple of problems with this approach. And when you iterate over all of these entity healths, you'll find out that actually a lot of them end up being empty. See, I wonder how... I'm just going to re-record that whole section again because I forgot exactly where I ended my last sentence and where I'm going to fit in. I can't play it back now. You're going to waste cache searching components, and entities with components are going to be scattered and more waste. Yep. I think there's more to it. I think there's more to it. Yeah, that's probably right, isn't it? Yeah, I think the problem is I started thinking about it and then lost where I was. There's another type of scene which is entity, or whatever you pronounce it, is using, where you simply have an array of component type and sparse hash map set. Yeah, you can change out the array types as not an array anymore and use the hash table there instead. Yeah, that's been a thing for ages. There's also like a redirection map as well, where you could look up into a big table which has, and you say if you can look up into a table that gets you an index, and then you look up into a smaller table, so yeah, they'll be more tightly packed, but there's different data structures you can use instead. But yeah. Yeah, more entities need to compute and wasting cache with useless entities evicting useful data. Yes. That's a good way of saying it there. Castor, thank you. Oh yeah. Yeah, well, they store 0 because all they need is that bit set. Yeah. Neat. Right, so I forgot where I was with this entity pool thing. So I said we're not going to... There are still some downsides. That was it. Yeah, I remember now. Right. Okay, so you might be thinking that now that we've got all of our properties in a nice array, just iterating over all of that whole array for the properties that we want is just going to pick up everything in cache and it's going to be great. Well, there's still actually some more problems to solve, so we're just going to look at those now. So if you take a look at the entity pool, we've got a bit of an example here where, it has this bit set where not every entity needs to have every component. So really it's going to create holes in the data when you scan over the array. So here's an example. The coordinate is fully enabled, it's just there for every single entity here, from 0 to 8, whereas health is only around for entity number 2. So when we scan over the health stuff, we're going to be scanning over these guys, and these are not going to be entities with a coordinate and a health component. They're just going to be, ones without health, so they're not going to apply to our algorithm, which is find the closest entity with the least health. But then finally we find one, and then we can run that logic, right? And so there's a bit of wastage by scanning over useless entities here. Yeah. There's also more wastage where we haven't really got rid of that problem that we had before. We've just changed it out for another one. What we've gone and done is, instead of having useless fields from that belong to the same entity, instead now we've got useless fields from other entities which don't have a health property. So we're still pulling in caches with useless data. Right. Okay. So this is where the archetype. Yeah. So this is where having a pool per archetype solves this problem, right? Because you can guarantee that every single field is going to be used by every single entity inside this pool. So that's going to be really, really helpful. So when we scan over all of those entities, we know that all knights have health. So it's going to be very efficient in that way. But of course, you can also add that properties bit set to these archetypes, but you know the trade-off where, like, maybe it's a very rarely used property, or maybe only one or two of them disable it, right? So yeah, it is a trade-off at the end of the day, but you really want to avoid it where possible. But I haven't told you the whole story, and there's more of a problem. Here we go. I haven't told you the full story. Having a graph between archetypes, say you have component C, and so it knows which archetype to traverse to the opposite. Like removing a component from B goes to... Yeah, Flex does that thing where Flex is basically, so people don't know, Flex is like an ECS implementation. It's basically a dynamic data structures library, in a way, a pooled dynamic data structures library. But something also that I learned about Flex is that if your parent ID is different, you're also in a different pool, from my understanding. So if you have an archetype pool, you've got to have the same parent to be in the same archetype pool, which is kind of crazy. But you see why they probably do it, though, for like locality reasons. But if you just have like an entity that moves around the world, and you got like, you got somebody that follows you around, well, you're going to be its parent. That's going to be in its own pool, just in its own pool. So it's a bit silly in some regards. We need to be aware about that design when using Flex. Hey, Kept Payne, how you doing, sir? Making all the time make each entity gets multi-threaded. Oh no. Maybe. Nah. Well, it is going to be multi-threaded, right? And it's going to be multi-threaded in a different way, where we will have a job system with read-write dependencies and things. So, although Archbase is not really ideal because if you have a lot of... Alright, Architect base is not really ideal because you have a lot of archetypes that they all share the same component. What's his rate? Only over this component. They'll frequently jump between chunks, which is not good. I'm not sure. No. I'm not sure. Yeah, if you maybe have tons of archetypes that don't really have tons of instances, is that true? I think as long as you populate, as long as you populate, as long as you populate the pools with enough data, I think it should be okay. Right. Now here's where I didn't tell the full story, so I'm going to tell a more fuller story. So, again, you might be thinking, great, now that we use archetypes, we just iterate over... Oh, for crying out loud. So you might be thinking, you know, if we got to use archetypes now, we don't have the problem where we got holes. Oh, for crying out loud. I did it again. Right, that's correct this time. Right, so you might be thinking, now we're using archetypes, there's not going to be any holes in our array, in our property arrays, because every knight that's allocated is going to use all the properties, so they're guaranteed to be there, right? Well, since this is a knight pool, we're going to be pool allocating these elements, meaning that we can individually free and allocate each element in the array. And that's the allocation strategy we're going to be using because it's nice and simple and it's kind of fast as well. So because of that, it creates holes in the array. So if we say allocate all 8 of these slots in the knight pool, and then we deallocate 0, 1, 3, 4, 6, 7, what you've gone and done is created some holes. So how we get around this problem is we need to not be directly referencing the entity in the pool, the offset into the pool for this entity. We need to have a level of indirection here such that we can have an automatic defragging system that simply just reorders the pool such that the data is next to each other as possible. So we should be able to have a defrag system that runs at the end of the frame that will take element 2, 5, and 8 and squish them down, or just move them down to 0, 1, and 2 and update the references to them in some lookup table somewhere. So if you give someone direct access to where the entities are in the pool, doing a defrag system like this is going to be harder because you'll have to chase every reference throughout the whole code base and somehow update it or have a way of renewing it. You might keep these pools in check, but just imagine a lot of components in a highly systematic game which would naturally create lots of permutations of these components, which will produce lots of pools. This is very specific game scenario, but for some games it would be true, I believe. Right. Let me read your original thing. Lots of archetypes that all share one component. Right. Yep. Potentially. Yeah, you can do the swap removing thing, or the move the back one to your position. It's quite a good technique. We might possibly actually do that. Hey Isaac, something I've been thinking about could really be neat to have in this ECS, to have in an ECS, is some way to make everything required for rendering contiguous to memory. Then you could just simply memcopy everything to the render thread. That sounds pretty sweet. Yeah, you could probably do that. Like if we do archetypes like this, it'll be possible, but there'll be a series of different mem copies. Not a bad idea. Not a bad idea. Trivial mem copy. But to be honest, sometimes you don't want a trivial mem copy because the whole idea is taking the data and transforming it for data for the render thread, right? And it's not necessarily a trivial copy like that. Because you don't want half the stuff that's in the game logic, right? You don't want to copy all the game logic. You also don't want to copy just like the mesh ID because you want more than just the mesh ID and you want to package it up. And also transform it a little because there's a benefit to not just copy in memory because you can transform it while you've got it loaded. Hey, Ransel. I basically moved to Fulham now, but I have to convert in our concert in Norrköping. Probably butchered that one on Sunday, so I'm going back right now. I said I was training up north on Sunday because it's start Monday morning. Interesting. What have you moved for education reasons or work? And also good to see you, Ransel. It's been a while. Right. What did I last speak about? Oh yeah. Then right, so I think this has solved the problem, right? It has, isn't it? So has it solved the problem? Right. Yes. Right, so now that we have some defragger in our system, you know, we've basically solved the problem now where we can iterate over all the entities in the pool in a cache efficient way. But there's another problem. I'm going to be having 73,000 entities all across a bunch of different worlds. So obviously I don't want to iterate over every single entity. What I want is the entities that are near me in 3D space, or maybe on a 2D plane, but yeah, in 3D space. So what we actually need to do is organize the data in such a way that all of the entities that are nearby in 3D space are also nearby in physical memory. Tetris for some reason. I don't know. It's like a rebel from Star Wars. Darth Vader, no. Right. So imagine if you have a world where you break your world down into, you can call them maybe chunks, a bit like in Minecraft, or you can call them zones or regions. So you can have maybe like different entities in these zones, right? So there's a nice little quick tree. And a good tree. That was a bad tree. That tree went bad quick. Distinctly make it look like a tree. There we go. Good tree. So you can imagine you got this game world, we're looking top down because our game is top down. And you can kind of break the world down into zones. Or you can call them regions or maybe chunks. And the idea is, say we've got this guy here, he needs to be able to look at all of the entities, like iterate over all the entities that are nearby, which have the lowest health. So the approach that I've come up with is we actually need to have pools per chunk. And then we can iterate over those pools per chunk and check all of the entities within a close range. Yeah, like a mushroom. Much better than the previous one looked. So you can imagine if I had an attack which had a radius of this, the only region I would have to check is all of the pools, all of the different archetype pools for this region of space here, and just iterate over all of the entities that live inside that region of space. And therefore, you know, I've found all of the entities with a particular health, and if there isn't any, well, say that one again. That was very silly of me. And let's draw another man. So you can imagine, like, if this is an AI here, and we're running that algorithm again where we're saying, find all the entities that are near me that are closest to me with the least health, and do some sort of work out which one takes priority to attack first. So imagine if the attack had a radius like this, or like the player has a radius like this, is very blind, doesn't have fast sight. You would simply just look up all of the entities within this region, all the different archetypes which have health and which have a coordinate property, and iterate over all of those. We'll iterate over this box, we'll iterate over this little person here, and this, I don't know what that is, a coin, I don't know. And we would find out that they're actually too far away, so we won't bother, looking for another, like this search has failed, it hasn't found anything. Now let's extend our box. Our radius, or is maybe this like ellipsoid thing here for some reason, I don't know why, because we're looking this way and we've got supervision. So now the regions that we need to look in is this region and this region. So we look over all of our entities, this one, and this one, because these are the different archetype pools, and we discover that this one has a health component and a coordinate. So we, get the length of the vector and get the health, and we've got a score for this one. Now we iterate over all of the entities in here, and we find out that, you know, this one has a health component and also a position, so we get the vector, get the length, and make a score for this guy. Now we've searched over all the entities, we can simply just go and attack this guy. So with this approach, it should heavily cut down on the amount of entities that we need to actually search. And when we're searching over entities, we should, as soon as we pick up one entity, if there is more than one entity, we should be able to hit, like those should already be loaded into cache, and we should be able to operate on that data more effectively. Right, so I think we've just discussed the key ideas there. Has anyone got any questions about what has been said? We haven't talked about how we're going to achieve this though. Right. So there is a couple of things that I want to address, and that is that doing this archetype approach is obviously far more complicated than doing this mega entity approach and doing any form of like structure of arrays is far more complicated than just doing an array of structures thing, right? This is way easier to debug and implement these arrays of structures, but structure of arrays is more complicated, and furthermore, archetypes are also more complicated as well. So the approach we're going to take when dealing with this archetype solution is we're going to make a little code. So the way we're going to tackle this archetype pool problem is we're actually just going to make a simple text file which lists all of the archetypes and all of the properties, and then we're going to have a little script which generates all of the code to do structure of array and array of structure archetypes, so we can compare speed and also make changes to the code generator and just add new fields to the text file and change the code without spending a lot of time doing it, right? Once the code generator system is in, we just operate on the list of entities and properties, and we should be able to change how the system works under the hood without too much of a pain. Yeah, hopefully it's going to be good. So we should be able to have an API which is stable. We won't be able to directly reference things, but I could feel like it could be a pain in the butt to debug. That's my downside with it. Yeah. How I intend on storing archetype pools. Yeah, so the way I'm thinking about doing it is every world, because there's going to be a few worlds, gets one big array allocated, and then we subdivide all the chunks evenly. So there's only one allocation per property, per archetype per property. So that should be reasonably okay. So we're not allocating it per chunk, per archetype, per property. Or separate pool arrays for each permutation. Pool arrays. No, what do you mean by each permutation? Are you talking about different archetypes, Clarissa? But I wonder if it's worth giving each archetype pool properties bit set. Yes, the properties bit set is great for flexibility. I might, because we're doing a code generator, I might add a bit of syntax where we say this field is optional and that's a cost that I'm willing to pay. basically saying all of them are probably going to use this thing, but basically 10% of them won't. So it's a price that we'll pay, and maybe they're only like a byte big, so it's not really that much of a cost. So yeah, maybe we will have properties bit set, or maybe some of the fields use no size. So the properties bit set would be the storage, right? So because all you need to know is you have that component or not. So yeah, that's a good point as well. Separate pools for each permutation. Yes. Yeah. Yeah, that's it. Maybe we just have a pool for each permutation, and then generate that, and then take the 3D chunk coordinate and then index offset into that array. That might be a good approach, actually. That sounds sensible. If that's what you're saying, Glorious Sir. Let me for each entity, I mean for properties of that pool. Bit set for the pools. Have health, right. Yeah, because I'm doing code gen, I'll be able to have metadata. So I'll be able to make a function which says iterate over all healths. Or iterate over all positions, and it'll be able to know all the properties from all the pools. He says it's fun. I wrote one when I was studying. It was terrible, but it did have a nice API where I could just query for. Yeah, awesome. Yeah, they are a bit of fun. They're also kind of. I really like the flexibility aspect sometimes, but also they can get quite complicated. And yeah, sometimes the most simplest solution is just having a big old strut. I've done that one in the past for prototypes. It's been quite nice. Yeah, only if you have a handful of entities, definitely. Right, so there's that downside with the archetype still, the debugging and the... So accessing the... Yep. Right, so we still have downsides with this archetype approach that we just have to be aware about, and that is that now we've gone to this structure of arrays, that the debugging experience is going to be a lot harder. So if you just had a structure and a pointer to it, you literally just look it up and, you know, look at the field and print it out. But what we have instead is these big pools, and you have to have like get your entity index and index into it to get the value that you want. So doing this in a debugger will be a little bit harder, but if we also have printing that we can still do though. Right. Anything else about the experience with the archetypes? Right. So, okay. So we'll probably have like a coordinate. Do you want to call it like a chunk coord? Chunks all the way, or a region? I don't know. Yeah, so U32 XYZ, yep. Yeah, so the cool thing is we're doing a code generator, so we can just swap it out. But yeah, definitely. I could probably make it do swizzle the components too. That's the hope. So maybe you can swizzle all the X's and Y's and Z's and have them all in one big array each. Right. Okay, so for the allocation strategy that I'm probably going to go for is we're probably still going to have one big night pool, one big chest pool, and one big tree pool. But per world, we'll probably just allocate these pools, and essentially each chunk is going to have a fixed size amount of nights, a fixed size amount of chests, a fixed size amount of trees. So, you know what? I'm better off drawing this because words are just not as good sometimes. Night. So let's talk about how we're going to actually allocate these archetype pools. So what you can imagine is that for the whole world, we're just going to allocate one big chunk of memory for each of the properties. So here's the night, and say here's the coordinate property, right? And what we're going to do is so imagine this is a chunk, and this is another chunk, and this is another chunk. And then each of the chunks have their entities inside there, right? They've got their arrays of entities, and there's possibly going to be space back here, but that is going to be okay. So our chunks are going to be inside. So on, click that one again. Right, so let's talk about how we're going to allocate our memory for these archetype pools. So I think we're going to have one pool per world, and each property is going to be allocated. So let's talk about how we can do the allocation strategy for these archetype pools. So we're going to have one of each archetype pool per world, and each property is going to get its own allocation, right? Allocates one massive array to store all of the entities for the whole world. So we're going to fix allocate the chunks from here. So imagine this is at the chunk of the world at 0, 0, 0, and all of the entities are going to be stored in here. So this only has 3 entities, and this will be at 0, 0, 1, and this one will have maybe 2 entities, and then this one is at 0, 1, 0, for instance. And this will maybe have like 4 entities. So you'll notice that we are still going to have this sort of like spacing between these chunks, but we've max allocated how many night coordinates there can be within each chunk. And when we have to iterate over these, we can at least iterate over these contiguously, then jump to these ones, iterate over those contiguously, then jump to these and iterate over these contiguously. But that's only if we have operations that span these 3 areas. Which should hopefully be, oh, actually no, maybe it won't be quite rare. It could be, depending on how big the chunks are. So there'll probably be a trade-off between like a chunk size and how big you want the chunk size to actually be, because the smaller it is, the more chunks you have to search and pre-allocates as more holes. but the larger the chunks are, the more entities you'll fit into a single area, but the more entities you'll have to search. So there'll be a nice trade-off there to make at some point. I'm not convinced that breaking into XYZ arrays is a good idea. Most of what you want to do on vectors can be easily done element-wise, so it doesn't really matter, right? You can probably... Right, I got fit in. Okay. Yeah, so possibly, yeah, like a dot product, right? It's just... Oh no, like a dot product. Well, yeah, doing like an adding, subtracting, multiplying, but dot product would be different. Yeah. Yeah. But the best thing about the code generator is we can just write the code generator and this will all come automatically, hopefully. We'll keep an eye, when we design the code generator, we'll make sure we can switch between the different versions and test them all out. Could we do that? We should, Actually, no, we couldn't. We can do it for the SOA and AOS, but for the different XYZ arrays, you would maybe need to get the... Yeah, we'll probably have to build a special API on top of that. But... Yeah, Yeah, I'll think about it. I'll probably keep it... I might keep it to be like an XYZ position for now, like not swizzled. And in the future, just... You know, we'll think about it when we write the code generator. We'll see how it looks. So essentially we need a chunk coordinate would be part of the ID. Yeah, so essentially you'll load a chunk coordinate out and you'll load an index into the so you probably pack that down. So when you have like an entity ID, so you might have an entity ID still, which is typeless, but you'll be able to get the type. We might store the type in the handle, or we might store it in the... Yeah. So this would be an entity record or something, we'll call it. You can do node, you generate as AOS versus OA. You get one extra indirection, but it's probably not that bad. Right. Maybe. Yeah, I'll have to think about it. Maybe it is possible. That'd be really sweet if it is. Right, so one of the downsides of the archetype is that if you have like an ID or a pointer to an archetype, it's kind of typed, you know. So one way around this as well is right. So one typical problem with the archetype is that if you have like a pointer to an element of the archetype, or just these pools, you with an index to it, you could see that as being like a typed thing, like a strong typed thing, and maybe you want that, sometimes you really don't. So we're going to have this sort of untyped version, which is just an entity ID. Since when we want to access our entities, we typically want to access the ones that are near us, but sometimes you're going to want to be able to reference another entity, which is kind of like random access. And this one isn't designed to be fast in any way, because random access is going to be slow. But we're going to piggyback off that and be able to now, I explained that in a very strange way. Might be difficult because you need to do pool.chord index needs to be generated as. Yeah, exactly. It's the usage code that's a bit of a problem, isn't it? Yeah. Oh, yeah, and the arrow. Oh, you avoided the arrow, right? Yeah, good times. Right, so we also want to support some level of random access to an actual entity. And as I mentioned earlier, we have a sort of defrag process, so we don't want to have a direct reference to an entity within an archetype pool, because we want to allow the system to be able to defrag and move the entities around and keep them more contiguous. So we're going to have an entity ID. It's probably just going to be an index with a counter bit in there or something. So if we free it, we can keep track of reused IDs or something like this. But we're going to index into an entity record array, and then pick up what is our chunk coordinate, our archetype, and our element index. So we should be able to know what archetype to look into, which element within the archetype array, and then also a chunk coordinate, so we can offset by the chunk and then offset by the element within the chunk. Another benefit of doing it this way is that you can have an entity ID to any entity, and it's not specifically hard-coded to a specific archetype, which can be quite problematic when you use archetypes when you have pointers, because it's strict typing. But we probably also want to have strict entity IDs for different archetypes, because then maybe it could make the lookup a bit quicker. I don't know. Yeah, so that's cool, isn't it? I think I've already explained everything I need to explain. So should we just start making a let's record an outro, then we'll just start doing the whole sort of like standard. We'll start designing. Or let's just start designing stuff, I think. The system. Not sure you mentioned it, but you could also make pointers to the pool to be relative pointers, or make it fixed size and generate functions that would return pointer to fields from base pointer. Pointers to a pool and then be relative, right? Then use an index, right? Like a fat pointer, I guess. Oh, I see. Yeah, no, I was going to do something like that. What you're saying is yeah. Is getting like doing the lookup and getting like an offset. That's a good idea. Caching the lookup. I did think about that, but I completely forgot. So we can maybe call this like an entity ref. Right. Is it possible to put type reference into and make it look up faster because you're in, to put a type of reference into that so it would make look up faster because you know in which pool to search? You'd need a switch statement with the untyped ones. Whereas if you had it hardcode, if you had a compile time type, you wouldn't need the switch statement. But you wouldn't be saving too much. I don't think. So there's also something else we will be able to do is maybe at the start of the frame, you want to look at the same entity like multiple times throughout the frame. So what you can do is you can boil it down into an entity reference. So the entity reference is effectively a boiled down version of this entity record that's just passed around instead. So you'd know basically how to index directly into the night pool and get exactly the entity you want. What's the way of saying it? Cheap viewers. Or maybe you have like a night reference, isn't it, or something? Right, so another thing that we could do is actually just get references directly to objects, but because we have that defrag process that's going on, these only will be actually valid for the duration of a frame. So at the start of the frame, what we could do is use like entity ID or that night ID, fetch the entity record, and generate a single offset into the night pool, and we'll call that night reference. And so if you're accessing the same night multiple times, it will mean that you can avoid doing multiple lookups into this entity record table before you go and look at that same night, basically. Yeah, I think that will do. So I want to design, I think if we do the outro, then we'll actually just get on and do the design of the code gen format. And then we'll start writing a simple code generator and just keep extending it until we get what we want, and probably have different, we'll play around with all the different ideas that we've been discussing. So let's just do the outro quick. And I've got to find time to edit these videos. Quick outro, then let's do more things. Right, thank you for watching this video. Okay, do I usually say that? Right, that's it for this devlog, guys. Thank you so much for watching. And if you want to catch more of the content, you can catch day 150 on the VOD channel, which is here. Or there's also the Twitch streams if you want to tune in live and come and hang out there. Or if you're too busy during those times, you can also join the Discord and chat on there with the whole community there too. And also, if you want to get source code access to the game and the engine, that runs on Windows and Linux. Oh, words today. I'm so damn tired. Let's retake that. You can also add a property to the pool that has an index in the record array. So when you defrag, you can just update the record index. Quite a bit more data though. Right. Yeah, that's a good approach. Yeah, maybe. Yeah, because how else would I do it, isn't it? Because like when I'm defragging, I think that's the only way I'm gonna have to do that is I need a way to store it in the record array. Yeah, maybe there's other techniques that we could do. But yeah, that's true. Right, that does it for this devlog, guys. Thank you so much for watching. If you want to catch the stream, it's day 150 on the VOD channel here. And then also there is a Twitch channel if you want to come and watch this live and come and hang out. There's also a Discord channel if you want to come and hang out off stream and outside of the YouTube channel comment area too. And yeah, if you want source code access to run this on your machine, if you support via Twitch or Ko-Fi, as a thank you, you get source code access to the game and engine to run on your local machine. Thank you so much for watching, guys, and bye-bye. There we go. Done. So let's move on to not worrying about making a devlog and talk about the code gen stuff. So let's make a new file. I'll open up a new file called so I think I'll go in the scripts folder to make the script, and then we'll probably have a we'll probably call it logic. The other word is simulation, I guess. Game logic is what I use. We'll probably call it entity. Or maybe ENT to keep it short. Entity is probably alright though. Then in here I think we want to do the thing. So entity it's worth doing an SO implementation so you can compare the code and output to. Yes, definitely. Wait, it's worth doing a reference. Yeah, I'm going to code gen both versions. So I'll code gen a structure of arrays and AOS version. So this will mean that I can just switch between the two and then get different results, hopefully, in terms of performance. And then also, yeah. So there's probably going to be entity.h, that's going to have all the base stuff in it. All the stuff that's not code generated. Then we'll probably have an entity. Let's touch all the files in there. Touch entity.h. That's going to be. It's also going to include the code generated stuff. Entity C, again, all the common stuff, and then include the code gen stuff. We need ways of describing probably properties. Dot I could just call them properties and then the other one entities, but dot list, I don't know. So it's probably I don't know where else I want to stick the list. It's going to be a custom format for sure. But if we stick all the properties in its own thing, it means that they're explicit. But also we could just stick it in one big file. What's the problem with that? Yeah, let's make sure that the code gen for the SOA version doesn't have some weird performance characteristics. Yeah, properties are properties. This is what I want to avoid. Or I could just call it properties though, or just entities, but then it's or archetypes. Yeah, I think the whole point of the code gen is I don't want to maintain a reference implementation. That's the main issue. Putting it all in one file is probably a good idea. Would you call it like a schema or something? It's so damn enterprisey, that word. Schema. Oh, is that what it is? Yeah, form or figure. Let's do it. Schema.schema. Let's call it schema, maybe. Sound like I just made a business. If someone's got a better name than schema, please tell me. I do not like this name. So I think we can basically just have like the properties up here. We'll probably do something where it's like and then we'll probably have like the archetypes. I don't know what the format's going to be, but let's just write something out. Manifest, layout. It sounds like Android manifest to me. Layout. Entity layout. Maybe. Make sure I'm spelling that right, yeah, archetype. So ideally I would like to be able to say define some form of property. So I could do like, I put the data type in and then the field. We can call it like speed coordinate. But we probably want to give it like a big old name as well, maybe. No, it could probably take that and then uppercase it. That's not too hard. Or we can make them all implicit. Or this could be done implicitly. Yeah, maybe it should just be fine implicitly. So you just define your... No, but you might want to say mark this one as like swizzle. You know, mark it as swizzle. Or something. Or maybe they're always swizzled. So with the archetypes, you could probably say something like or maybe we just do prop. Yeah, this would be a bit easier when it prop this, that. And then a semicolon. Why not? Archetype. With the name. So we'll call it the knight. It has a coordinate So you would want to list all the properties, I guess. Well, my issue with it is the maybe they won't go that wide, right? We can all keep them to one line. Maybe. Yeah. Yeah, cargo. Cargo, maybe. But yeah, schema. I don't like this name. This is bad. Yeah. Hmm. Hmm. Maybe I'll go with layout. It seems the most. We'll call it entity.layout. Done. So, yeah, we just want to try and figure out, like, you know, I guess we just take all these things, right? We're like prop. U8 health, maybe. Or maybe support spaces like that. And then we'll probably add something like E32 mesh ID. Obviously, it supports more types than these built-ins, right? But it's just a way of code generating and getting it all compiling. We'll probably have strong types, and these things will probably not exist anyway. Weapon ID, armor ID, armor. So yeah, we'll just health it, mesh it, weapon it, armor it. What if you want the same name but different type? Yeah, that is a good question. I think the problem with that is it would make the definition syntax more complicated, and I would be defining more. There'll be more lines, but maybe this would be quite annoying to filter through because it will be kind of because I'll have all the archetypes squished up so close to each other. Yeah, I think having unique names is fine. I don't think I want a different type with the same name. That just means it's more. Right. Or maybe you can override it with something like this. Yeah, maybe. Yeah, I think distinct names is just good though, because if it's health, I know it's always that same data type for health, right? It keeps consistency. So it's good for that reason too. What was the other one? There's definitely tree and chest. Yeah, chest. Oh, I missed out the inventory. Let's say the knight doesn't have the inventory. Health has chest though. You can smash it. And the other one is tree. Missed the mesh ID. So, right, so about this syntax, I imagine if you have it all, like, things won't necessarily go too wide, I don't imagine. Not having the types there is making it harder to... maybe if I get familiar with the types, it would be okay. Yeah, it's just kind of armor. Yeah. Steel plated chest. And imagine if we have them all sort of swizzled everywhere, looking all over the place, the different fields. It might make it a bit harder to read, but you should be able to find... Yeah, I think this is good enough for now. We can always change the format, right? But I think that's kind of cool. Yeah. So I guess let's talk about this code generator then. It would probably be something like just a script. We'll call it entity gen .c. And I think it's just going to be a plain C program. Good old argc argv. Then return 0. And I think that this is probably the wisest idea. And we can always just we can always include parts of the engine still. But I doubt we'll need to. We'll probably just add our own string manipulation thing here, maybe. I don't know. So, maybe including the engine is fine. Maybe we could say include. Well, the problem is if I include core, it includes a lot of other stuff, like the operating system. But yeah, so if I just include core, it should actually get the operating system and all the custom allocation stuff. And maybe that'll be useful. So I just include for crying out loud, I didn't even pick it up. Right. core.h. That will include core C. And then we'll want to include Linux. Yeah, so os.h, and then probably Linux as well, come to think about it. If Linux... Have I got those sort of special if defs or not? I don't think I have. Yeah. Wait. Why ain't I just in this, you know what I mean? Wally. Cool, so this means we have access to all of the bits of code we'll want, and we can always add more specifically for scripting for these sort of code gen scripts. So we should also make a open script entity gen.sh, do the lovely old shebang /bin sh, clang-o build/entity gen scripts/entity gen.c with the include directory of source. So let's make sure that works. Does it at least compile? So give it executable permissions, execute, core not found. Oh, it's an engine. My mistake. Maths. That's in the third party, isn't it? Where are you at? Ah. I don't know all those. Yeah. Right, let's join all those up, maybe, or we can do this. Cool, let's try that out, see what happens. B stack trace, DL info is not declared, wasn't it? Or not? My OS thing declares main. It's alright. Where's DL address? But why is that not included in B stack trace? Why does my main get away with that? Include standard IO at the top. That's probably why. Nope. So how does my... Oh, it's the C file, isn't it? Right. So include the C files last. OS will include the right stuff. Nope. Games.h. I don't even know what's going on. So we should probably include man DL address. This one. I'm not sure why that's not included inside bstack trace. Not gonna lie. It's right here, bro. That's if it's Apple. Linux is here too.
Ah,
Is that still okay? No, it's not. Right, should be back. Maybe it's just claiming funny because of the main definition. Maybe. Maybe. In my project, all my OS stuff is in one folder, then the app just includes OS. It's also the underlying OS includes. Yeah, probably a good idea. Well, yeah, maybe I should have put. Yeah, maybe I should move the OS C files. Yeah, so basically, I already do that for os.h, but not for the C files. Maybe these should also be included into this compilation unit. Maybe. But that's a good idea. Mm-hmm. Yeah, maybe we just always. Those are the bottom. Yeah, it's alright. It's an improvement. Let's get that out of the way. Mm-hmm. So my application to figure out. Yeah, exactly. Yeah, I think core. Yeah, core includes os.h already. I think. No, OS already includes core. Yeah. I have different entry files for each OS. They include all the game stuff. Wait, your OS layer includes the game stuff? I'm not sure if I understand that one, Clarissa. Yeah, I think I need to call this game main. Right, so the main one went. Um, 381. If Linux include this thing. What? It's doing it. Like, oh, it's not got the GNU source thing, isn't it? For crying out loud. So basically, if you know your Linuxes, you can't get by with a little bit, without a little bit of GNU source. And voila. Why don't I have a core header? Have I accidentally deleted it or something? No, it there. I didn't put a backslash. I need to link against all these things now. I need a game crash handler. Assert failed. Maybe I should just link against Vulkan. Or whatever. Right. Windows game, Linux game. Okay. Right, so different main files. Okay. Hmm. So I need to link against all these buggers. I guess this is where it would be nice to simply not do that, but it also... See, I could just look at this file and just link against it all. Yeah, warn VLA. Yeah. Um, I'm alright with that for now. I think that's a good idea. Build script. Let's just get it all in there. Here we go. Unused parameter. No. Anyway, we've done it. That's good. So we can reuse the core parts of the engine at least and get, we're doing more code generators or whatever, an asset builder or whatever, or a build system or whatever. I don't know. We can just use that core functionality and it should be all right. So that'll be sweet. Mm-hmm. Yeah, HTML, I remember those days. Still remember some of that knowledge, unfortunately. It should be out of my brain by now, you know? I find it handy to separate main files for each OS because you can do whatever OS wants to handle its events in the game loop without having to bake into your abstraction layer. Right. So you're talking about the window event system. Right, I see. I never thought about it that way. It's interesting. Yeah. Nowadays, these kids in the new programming languages. Yes. I did Rust once. I'm alright. Yeah, I think that's exactly the same for me, Jack. I just have an event list that I loop over, but I've still got to deal with the Windows system properly and put that on another thread or something. I still haven't handled my Win event system, whatever that's called, I forget. But until then. So the main idea is we need to be able to read in a file. File read all. Amazing. Past Henry has made an API. Such a wizard. So returns a boolean. Success, I imagine. It's what current Henry would do, so hopefully that's it. So it'll be in the source directory, logic, entity dot layout. Data out. What? Past Henry has ruined me. So I'll just allocate a big old buffer. Char star. Layout. Bytes. Layout. String. Malloc. Did someone say malloc? 1 megabyte. Ought to be good enough. Oh no, it gives me it allocates it for me. Yes. Do 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 do. I completely forgot about that. Voila. Right, so I'll read in a file. Return success. So it returns 1. We win. Hash embed. Ooh. Yeah, hash embed is pretty sweet. Oh, mmap. Yeah, mmap is a good API. It's pretty sweet. Get it? Just mmap the file in. What do we do here? We didn't make the crash handler, and where's my damn... I didn't include the maths library. Hmaths. What else did I do? When did I include game.h? Oh, it's included in here, isn't it? I've included game.h in OS because it's got my custom allocators in there. What have you done? Right. We'll just include that one as well. For now. So we need that crash handler and handler. Let's get one of those. Legit. So with the crash handler, it was kind of nice to get... Anyway, generate stack traces and things. Do we need... logs. No, stack trace. Right, so we ran it. Oh no. There's a game exit. I need the game exit too. Cool. Let's roll with that. Finally, it builds. So now that it builds, we're going to, on that script, entity gen script, we're then going to say and run it. Build entity gen. Cool. So it did return 1, which is fine. Let's multiply it by 10. So it should either return 0 or 10, as an example. There you go, so return 10. So this means that we compile it and run it, and we're loading in that entity layout file. Obviously, we could have just printed the file out here. Should have called it string, really, rather than bytes. But there you go, prints out. Boom. So now we've just got to parse this into some data structures and then simply just generate another string, throw it out to disk in a couple of 2 strings. One's the header file, one is the source file, and throw it out to disk, and voila. Amazing. Right, I'm probably going to pack it there today, but we're going to actually make a start on this code generator tomorrow, Thursday. And then we'll probably be doing more code generator stuff on Sunday. So we'll probably do some basic implementation, see what it looks like, and improve on it incrementally, and see if we can handle doing an AOS version and an SOA version, right? Array of struts and structure of arrays version, just by adding a flag to the entity gen. Or maybe we generate both all the time and have a compile time flag to switch between them. And then the other one will probably be swizzling vectors. Can we find a way to automate swizzling vectors and toggle in between them with a standard API that works for both? I don't know if that'll be possible, but it might be. We'll see. Yeah, swizzling, so we can get X, 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 Y, 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 Z, 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 Z. Entity with an array of strut. Hey, Blamey. Yeah, we've designed it so it works for. It's going to be structure of arrays, but we're going to have an AOS version as well, just so we can benchmark it when we're actually using it and see, like, is there actually a benefit to this, and fix the problems if there isn't a benefit. Bum bum bum. Just find someone to raid. Hopefully I got that video up. Well, 2 videos queued up to be condensed down into a devlog, but I need to find some time. What am I doing? Meant to find someone to raid. Thank you for coming. It was wonderful to see you all. I'm so tired right now. I'm just gonna exercise, eat food, watch some stuff like a brain dead individual, and then yeah, watch some stuff like a brain dead individual. There's a C programmer, but it's like anime C programmer, you know? No, not this guy. Very much. Yeah, this is the way. This is the way. Anytime you feel exercising and you do it. Nah, probably just lifting some weights or something. I don't know. Eating food. Right. Have a good Wednesday, guys. Hopefully see you all Thursday. If not, see you all at the weekend. Have a good one.